Don't worry about it. We'll get there in a minute. Ooh, we could actually. Yeah, well, that's gonna be relative later. We might need that one. We could go get that one, actually. Well. It might be useful later. I know, I'm just gathering things. Me, I'm just doing stuff. Don't worry about Shepard. Calm down. We need that and that over there. Right? Totally. Okay. So, I bring this up because we'll be stealing a bunch of his shit here in a minute.
What discipline you're in.
Again,
in math,
I'm stealing your shit again.
Math, people really like a base of E. We'll see why next lecture. In, I don't know, I'll say engineering. But really it's anything where you want good intuition with our normal base 10 number system. Log means log base 10. And if you're curious, often in computer science settings,
so these will be the few of the questions, at least 5 of them. 1, 2, 3, well, like 4 of them. But this one's kind of an intuitive question that breaks you loose. We'll be getting into what that's about later.
Counts the number of zeros at the end
this
of the
thing
number.
is a monster.
That can get you a really far way. So we're going to start going through a couple of these properties, and I want to do this just
one of the biggest problems, 3B, and
so
Elon and some of the other ones is when you deal with this is what you'll have is the zenith. Elon, everybody else, Bill Gates. Without you guys out there to do this number, you're really missing. I'm missing the photoelectric effect. Like if I needed to help you with some subject matter where my Z-coin is, I'd give it to you. That's a log. There's also the kind of version where, because you're not integrating n1/2 into the material, some salty or sharps or some orientation of that ideal situation where I'm compressing those zeros into the set for a computer. I'm jumping some zeros, moving through some MOS chips here. You're going to lose a lot of people. They're still not going to understand why this really is, even if I go about showing them that, other than you're compressing some zeros. 5 zeros in there is 3 plus 2. Well, you're hijacking a lot of computer science inside here before you would want to get to what best describes your relationship with, or what best describes your relationship with logarithms. I have never learned logarithms. I've learned them but forgot. I understand them but only can explain. Well, he actually says that up to I understand them but I can't teach them, and I can understand them and I can teach them, and somebody else to teach them as well, or somebody to teach them C. So that's a pretty complicated question. Even already in the log, you might lose somebody at the tracking of that information, which is really important. And it's buried into the code, and he'll go through it real nut and bolt. I can't. That's electric field theory ladder to me, as far as I'm concerned. We got another one right over here. Same thing. And almost to a certain degree. Well, that's super important stuff, but you're going to be building more fields.
And like I said, when you're just getting started with
so again, we're just kind of taking that 100 space, and I'm saying inside of that subject space, there's a power, right? And that power is X, Y, and Z. That if I know the power, I've logged the set of the environment around me. And people that go into that inverse off of that, and equally, like if I had a group of people and I changed them to the Himalayas or the bottom of the ocean, the results of doing any task, 0 or 1. Is it beneficial to cook ramen noodle at the bottom of the ocean? No, that's more of a zero theory, but not impossible under the concepts of you could, and what would it take to do this? Well, obviously a biodome and some pressures and things, but you're compressing a lot of the zeros. And the human brain just doesn't get that stuff, guys. So I wanted to open up like that. Why would I do like that? Well, let's say that this was case studies of some of those students up here, and I want to screw with them a little bit, actually show you some of the mastermates for this. I'm going to unmake you right now. We're just going to destroy your everything in terms of math understandings as a concept. And then we're going to sit through the class. There's only 5 questions. 2 minutes of questions. Ask the question, word it through it for them so they know what it is, and that they actually, that's log or base B or base A. Well, that's what those words sound like. That's great. Get familiar with that in case those ratios inside of here later on. We'll skip that stuff because, again, that's real heavy about what you're doing. But watch how we're doing this fundamental here. What best describes your relationship with math? Never learned it, but forgot.
I'm being redundant. I'm saying this a lot.
I do math, but I can only explain what I do with it. I do math by teaching it. Now, again, out of a group of 18-year-olds, 25-year-olds, you haven't logged any of that extra information yet, which would be into the subsets of the information where you're going to be living about these logs, right? These log sticks. That's some pretty heavy combinations. They're divisibles of that. They're multiples of it. They're additions to it or subtractions away from it. And depending on how you're graphing it, obviously I'm looking for vector positions in the same class again to the same questions. Or how does it log differently now? Those are totally different results potentially. Now let's say for this case study again, whether it be what's your relationship, and these are all the same answers. Right, never learned it but forgot. I do math, but I can only explain what I do with it. I do math by teaching it. I want to know that answer. We're already off the hop about, I didn't tell you anything. Math, algebra, trigonometry, calculus, Lagrangian algebra. There's a lot going on inside of there about what I might be looking for as a logarithm for the QA program. And we'll get to computer engineering in a second here. About mathematics, chemistry. Right there, without chemistry, you have no mathematics. You have no atoms to count. Okay, what is your best describes your relationships with psychology? Again, if math is chemistry, psychology, then psychology is physics, math. Right? Because we're defining the words that apply to a number, to the deformation of that steel, or what kind of characteristics go into this. And of course, what is your definition of computer algorithm? Now, I had to make a bit of a jump, and I'm generally using this COVID check right here because I want you to understand this is about that probability or odds. In the next 30 days, COVID is going to be at 100%, and he pretty much mashed it. That is the goal, the photo of what we're dealing with this element. Right? Because what is the components of this ideal situation? Alright, so that's some of my notes on the logarithm, and you can get into vastly more complicated. We could just do a 5-pager on math concepts, just to feel, well, does somebody know Lagrangian algebra? Does somebody know bosonic harmonics? Is algebra trig something heavy, something simple? You probably want to go algebra, trig, geometry before you get into some curveball at the bottom. But you notice how that just went. We could just do 2 pages like that. Kind of start with trig or algebra, and then break down into a more complicated field of what that is to scutter that thing off to the Mandrel fractal, so 1/3, which you're going to get into inside of here of probability highs and lows. If out of this, not only are we looking for who can get the right answer, it could be a timed event. Maybe you could integrate some stuff in here, but just for the purity's sake of mathematics, here are 5 answers. None of the above is one of them, which you see, you look here, you'll actually see it. But you won't know this. This is my master's key, right? I'm going to be writing this stuff up on the board as we're doing it, looking as a key research, because I'd probably learn it's faster. You get a better average out of doing stuff like that coming into the stone mill with SawWorks. You log that. You log 2, but it's still only 1/3 of a 0 that's compressed as something I'm going to do to chemistry, or something I'm going to do to physics, or something I'm going to apply as psychology. So why is it important to identify what the photoelectric effect of what people perceive themselves to be? Well, it's not just that I need to do that. Again, I might be looking for a C++ program where integrating log 10 might integrate a population over time of multiplying. Well, every time we take a test, I keep getting roughly the same average stacked up comparatively to this version isn't going to do that exponential curve. I'm just every test roughly in these averages kind of hitting what it is. And only if the case of students were 50 or always 50, you'd have to map that. See, if you didn't log it like that, there would be different results. But it will still mathematically do what you asked it to do, so that's why the result may look odd or weird. Right, and then that inverses as well. So if what did I say here? Or what did the guy Max say? If the inverse of addition is subtraction and division, multiplication is division, then if the exoponianation's inverse is the nth routing, or logarithms, of it, could either one really be described that way? And this is this nature of, well, this is what bosonic harmonics is. It's a logarithm of states that says that these subject matters resonate off each other, creating a feedback scatter pattern, interference pattern, and then we can identify it with saying, well, what was that thing? This looks like an identifiable interference pattern. Well, how do you know? Because interference is when you log them over averages and numbers and their mean, behave like that. They do it mathematically by the numbers. They operate into logs or systems like that, and so that's how you know you perceive it. Again, when you look at a black hole, out of all those vector positions, they would share in common A plus B against other black holes, where that number is crazy outside of the scale. So when you're in the stone mill and you're seeing black holes like that, that's the lodge. That's an exoponent of that lodge, right? So if that exoponent is the nth route, it's an inversion of that pilot, right? I'm taking him, instead of being the log guy or the stonemason, I'm going to tell him, hey, that's what chemistry is. It's what mathematics is, what psychology is. So, and to a certain degree, computer engineering and so on. And I want you guys to get real fundamental with that. Like, did you graph it? Catch you on the next one.